the following flow patterns with their characteristics. Here the list 1 gives the flow patterns and list 2 gives their characteristics. Here the in list 1 turbulent flow, boundary layer separation, laminar flow and steady flow is given, and in the list 2 no change in flow properties at any point in the flow field, and the second point is highly irregular and rapid fluctuations of flow velocity, and third point is wave formation, and fourth point is smooth flow without mixing of layer. First consider the first flow pattern, that is turbulent flow. Generally turbulent flow is meant for irregular flow. So here in the given options it matches with highly irregular and rapid fluctuations of flow velocity, that is P matches with 2. And consider now boundary layer separation. So at the boundary layer separation there is a wake formation of the fluid, so it matches with third. And coming to the laminar flow is a flow which is well mannered flow, that means there is no mixing of layers or other things, so it is a very smooth flow without mixing of layer, so it matches with the option 4. And coming to the steady flow, there is no change in flow properties at any point in the flow field, means the steady flow. So here the correct matching is A is the right answer. Carries at drivable temperature of 15 degrees centigrade enters the heating coil maintained at 40 degrees centigrade. The air leaves the heating coil at 25 degrees centigrade. The bypass factor of the heating coil is, here the options are 0.376, 0.4, 0.6 and 0.67. So here bypass factor is the ratio of actual temperature difference to the ideal temperature difference. Here actual temperature difference is given by the temperature maintained, the maintaining temperature of heating coil minus the outlet temperature of the air, so which is equal to 40 minus 25, and here the ideal difference is 40 minus 15, so it is a ratio of 15 to 25 which gives a value of 0.6. So in the option the correct option is C is the right answer. Boundary layer occurs when, here the options are dou u by dou y greater than or equal to 0, greater than 0, dou u by dou y is equal to 0, dou square u by dou y square is equal to 0, dou u by dou y less than 0. Generally the separation of boundary layer occurs when either the pressure gradient should be greater than 0 or pressure gradient is positive, or dou u by dou y is equal to 0. So here in the right options B the correct option. Ideal output is given by 10 kilowatts, frictional losses in turbine casing is given by 0.5 kilowatts, and external losses in bearings is given by 0.75 kilowatts. Here we will have to calculate the brake efficiency of the cycle, and then the options 95%, 87.5%, 92.5% and 82.5%. Here brake efficiency is nothing but it is the ratio of the available power at the output shaft to the ideal power. So here ideal output is given by 10 kilowatts. Let us say this is PI is given by 10 kilowatts, and brake power is given by, it is the difference of the ideal output and the losses in the cycle, that is given by minus 0.5 minus 0.75, which is equal to 8.75 kilowatts. Now the brake efficiency is equal to the brake power to the ideal power and is equal to 8.75 by 10, which is equal to 87.5%. So in the option the correct option is B is the right answer. In CI engine fuels can be reduced by, here the options are either decreasing compression ratio or decreasing inlet temperature of air, decreasing engine speed or increasing cylinder cooling water temperature. Here generally ignition delay occurs due to the improper cooling, so that here we will have to increase in the cylinder cooling water temperature, then we can reduce the ignition delay. So here the correct option is D is the right answer.
We need to find out the value of I. Here means we have to integrate over the contour which is given where mod z equals to 2. So within the contour given by mod z equals to 2, there is only one pole, that is z plus 1. Means we need to calculate the residue at that point, that is I is nothing but summation over residue at z plus 1, that is e power minus 1 divided by 2, which is plus 0 at z equals to minus 3. Hence it is going to be 1 by 2a, hence option A is correct.
If A is an orthogonal matrix, then we have to find the value of determinant of A. So it is given that A is orthogonal. Orthogonal is nothing but A into A transpose, or A transpose into A will be always equals to I. Now if I apply determinant to the above equation, A into A transpose determinant equals to, so we can write this as A transpose is equals to 1. Now also we know that determinant of A transpose and determinant of A are equal. So we can write this as determinant of A square is equals to 1. So the determinant of A will be plus or minus 1. That is option D. If A dice rolled and is saying that A denotes the event of obtaining a number less than or equal to 5, whereas B is the event of obtaining a number that is odd number. Then we have to check which of the given options is correct. Now A is an event of obtaining number less than or equals to 5. So there are totally 5 chances. It could be 1, 2, 3, 4, 5 out of 6 chances. And B is an event of obtaining an odd number. Odd number can be 1, 3, 5. So there are 3 chances out of 6 chances. Next, let us see what will be the intersection part. That is A intersection B. A intersection will be again 1, 3 and 5. Now, what will be the probability of intersection of A and B? We have 3 chances out of 6 chances, which will be 1 by 2. And what will be the probability of B happening of event B? There are 3 chances out of 6, which will be half. Now, let us calculate the value of P of A by B. We know that P of A by B is nothing but P of A intersection B by P of B. Let us substitute these values. P of A by B is nothing but 1 by 2 by P of B is 1 by 2. So the value is 1. Hence option A.